Every spacecraft we've ever launched had a first photo, the triumphant one, the press conference one. But almost nobody talks about the other end of the story, because every probe also took a last photo. A final image captured moments before the power died, or the signal cut, or the spacecraft itself was deliberately destroyed. Some of these photos are blurry, some are incomplete. One of them is mostly static, and one of them, the last one we'll get to, was taken by a spacecraft that is still alive right now, flying through interstellar space. Knowing its final photo is already decades behind it. These are the last things our machines ever saw. In 1965, NASA launched Ranger 9 at the moon. Not toward the moon, at it. The Ranger program had one job: fly directly into the lunar surface, cameras running, transmitting photos until the moment of impact. No landing, no orbit, just a controlled, deliberate crash, photographing the ground rushing up to meet it. Ranger 9's descent was broadcast live on television. Millions of people watched the moon get closer in real time, frame by frame, the craters growing larger until individual boulders became visible. The final image cut off mid-scan. A partial frame, half transmitted, interrupted by the impact itself. The spacecraft photographed its own death at roughly 9,600 kilometers per hour, and the last picture is unfinished because the camera hit the moon before the photo could. 40 years later, we did something much gentler, much further away. In January 2005, a small probe called Huygens detached from the Cassini spacecraft and dropped into the atmosphere of Titan, Saturn's largest moon. Nobody knew what was under Titan's orange haze. It was the most distant landing ever attempted, 1.2 billion kilometers from Earth, on a world where the temperature is minus 179 degrees Celsius and the rain is liquid methane. Huygens drifted down under a parachute for 2.5 hours, photographing the descent, and then, instead of crashing, it landed, softly, on a flat plain scattered with rounded pebbles. Its last photo is the surface of Titan, those pebbles, sitting under a hazy orange sky. They look like ordinary river stones. They are made of water ice, frozen harder than granite, rounded and smoothed by flowing liquid methane. The probe kept transmitting from the surface for about 72 minutes. Not until its batteries died, but until Cassini, its relay back to Earth, flew below the horizon. Huygens may have kept talking after that. There was simply nobody left above the sky to hear it. The next one didn't land softly. It was never designed to land at all. The Rosetta spacecraft spent 2 years orbiting a comet, 67P, a 4-kilometer chunk of ice and dust shaped roughly like a rubber duck that has seen things. By September 2016, Rosetta was running out of usable power as the comet carried it away from the sun, and the mission team made a decision. Rather than let it slowly freeze in silence, they would set it down on the comet itself, instruments running the entire way. Rosetta descended for 14 hours. It photographed the surface getting closer and closer. Boulders, pits, ancient dust. Its final complete image was taken about 20 meters above the ground. A blurry, intimate close-up of comet terrain, so near that the picture looks less like space photography and more like the last thing you'd see falling face first onto a gravel driveway. And here's the detail that gets me. A year after the mission ended, engineers digging through Rosetta's final data stream found something. A half-transmitted packet, incomplete, never flagged as an image. They reconstructed it. It was one more photo taken even closer to the surface, sent in fragments in the spacecraft's final seconds. Rosetta's actual last photo wasn't discovered until a year after it died. It had mailed us a letter that arrived after the funeral. If Rosetta's ending was planned, the next one wasn't. The next one is the hard one. The Opportunity rover landed on Mars in 2004 with a mission plan of 90 days. It drove for 15 years. It survived dust storms, sand traps, a broken heater, and a front wheel that eventually had to be dragged. It covered 45 kilometers of Martian ground, a marathon on another planet by a machine designed to last 3 months. In June 2018, a planet-wide dust storm rolled over Opportunity's position in Perseverance Valley. The sky went dark. The solar panels starved. Its final transmission included routine telemetry, power readings, atmospheric opacity, which one journalist later translated into the phrase the internet has never forgotten. "My battery is low, and it's getting dark." That's a paraphrase, not a quote. Rovers don't speak, but its last photos are real, and they say the same thing. Frames from that final stretch show the sun shrinking behind thickening dust, and its very last image is a dark, incomplete frame, partially transmitted, full of noise. The picture cuts off the same way the mission did. NASA spent 8 months sending over 1,000 recovery commands. The final one was sent in February 2019, along with one last song transmitted toward Mars, Billie Holiday's "I'll Be Seeing You." Opportunity never answered. It's still sitting in Perseverance Valley right now, covered in dust, facing the direction of the storm. Cassini's ending was different. Cassini's ending was a sacrifice. After 20 years in space and 13 years orbiting Saturn, Cassini was running out of fuel. And that created a problem nobody had fully planned for. Cassini had discovered that Enceladus Enceladus, a moon it was never even prioritized to study, had a liquid water ocean that might host life. A dead, uncontrolled spacecraft tumbling around Saturn could one day crash into that moon and contaminate it with Earth microbes. So to protect an ocean it had discovered itself, Cassini was ordered to die. On September 14th, 2017, it took its final photographs. It photographed Enceladus setting behind Saturn, a deliberate farewell chosen by the team. And its actual last image is quietly devastating. A patch of Saturn's night side, dimly lit by light reflecting off the rings. An unremarkable spot of cloud, the exact location where, hours later, Cassini would enter the atmosphere and burn. Its last photo is a picture of its own grave. The next morning it flew into Saturn at over 110,000 kilometers per hour, holding its antenna pointed at Earth, transmitting science until the atmosphere tore it apart. The signal didn't fade, it just stopped. And then there's the one that breaks the pattern, because every probe so far took its last photo at the end of its life. Voyager 1 took its last photo 36 years ago, and it's still alive. On February 14th, 1990, Voyager 1 was 6 billion kilometers from home, its cameras long unneeded. It had finished with the planets a decade earlier, but Carl Sagan had spent years lobbying for one final photographic act, turn the cameras around, and photograph where we came from. Voyager took 60 frames, a family portrait of the solar system from the outside, and in one of those frames, suspended in a stray beam of scattered sunlight, there's a single point of light smaller than 1 pixel. That dot is Earth. Every human who has ever lived on that dot. The pale blue dot is one of the most famous photographs in history. What almost nobody mentions is that it was Voyager's last one, shortly after the cameras were shut down forever to conserve power. The software to operate them is gone. The engineers who knew how are retired. Voyager 1 is still out there right now, over 24 billion kilometers away, the most distant human-made object in existence, still faintly transmitting on a dying nuclear battery. It has flown blind for 36 years. It will fly blind forever. Its last photo wasn't a comet or a crater or the place it would die. Its last photo was home. Every one of these machines is still where we left it. On the moon, on Titan, on a comet, on Mars, inside 2 planets, and one of them out beyond the edge of the sun's reach. Still going. They don't know their missions ended. They just know the last thing they saw. If you want more stories like this one, the entire space playlist is on screen right now. Start with the life of the planets themselves. I'll see you there.